Heat and work. Heat and work are two different ways of transferring energy from one system to another. The distinction between heat and work is important in the field of thermodynamics. Heat is the transfer of thermal energy between systems, while work is the transfer of mechanical energy between two systems. Starting with heat. Heat is a form of energy that can be transferred from one object to another, or even created at the expense of the loss of other forms of energy. The symbol for heat is Q, and Q net is equal to the heat in minus the heat out, indicating that heat cannot be created or destroyed. There are two units of heat, British thermal unit and calorie. The British thermal unit is the amount of heat required to raise 1 pound per meter of water by 1 Fahrenheit. Calorie is the amount of heat required to raise 1 gram of water by 1 Celsius. Heat entering the system is positive, heat exiting the system is negative, and during an adiabatic process where there is no heat transfer, heat is equal to zero. The amount of heat transfer depends on the path that the system follows, which is the integral of dq equals to q, and the rate of heat transferred is the integral of dq over dt, and the specific heat transfer is equal to heat over mass. So there are three heating transfer modes. First one is conduction. Conduction is a mode of heat transfer that works when energy is given out by the molecules at a higher temperature to those at a lower temperature. So the Fourier's law is equal to minus Ka dt over dx, and it's negative, showing the direction from higher to lower. The second mode is convection. Convection is a mode of heat transfer where the bulk motion of a system moves matter with a certain energy level to a surface with different temperature. Newton's law of cooling is used to calculate the heat transfer, which is Q prime equals to AH changed in T. And finally, radiation is a mode of heat transfer where energy is traveled through electromagnetic waves in space. The heat is calculated using Stephen Boltzmann law, which is equal to epsilon sigma A Ts to the power of 4. Heat transfer through radiation could travel in empty space, however, its emission or absorption needs a mass. Radiation is distributed in several wavelengths, and only certain substances can absorb certain wavelengths.
So as we have seen, work is different than heat. In thermodynamics, work is the quantity of energy transferred from one system to another. It's a generalization of the concept of mechanical work in mechanics. In the system international, work is measured by symbol J, which means the joule, and heat and work are two different ways of transferring energy from one system to another. The distinction between heat and work is very important in the field of thermodynamics, and the transfer of thermal energy between systems, while work is the transfer of mechanical energy between two systems. So there's different types of work. First, we have the non-conservative work, which is the change in energy. The change in energy itself contributes to the change of kinetic energy, the gravity energy, and the spring energy constant. So for the change of kinetic energy, we can see the formula in there, and also for the gravity one and the spring one are shown. Next, we're going to see the units of work. When a work is positive, that means the energy is leaving the system. And when the answer is negative, work means the energy is entering the system. So we have also work done at moving boundaries. Three types of work. First of all, we have the constant volume process, which means when the change of volume is equal to zero. So there is no work in gas unless it changes in volume. This is what we should keep in mind. And for isothermal expansion, the temperature is constant and the work is done by nRT times ln V2 over V1, or if we have the pressure, we can use the other formula. And finally, we have the constant pressure process, which is in the cylinder, applying a constant force to get the work done by P is equal to the variation of volume. So there's also other systems that involve work. We have the electrical work and the shaft work. The distinction between heat and work is important in the field of thermodynamics. The first law of thermodynamics states that the heat and work are both contribute to the total energy of a system, but the second law of thermodynamics limits the amount of heat that can be turned into work.